Hi guys, welcome back. We're going to look at measuring and constructing angles in geometry. So we're going to start off by naming angles. So we have two rays when they form and connect. When they meet at the point they connect at, that is our vertex, and that is going to help us name our angles. So you can see in my first diagram here, I have my ray AB. Remember, we name our ray starting with our endpoint. And we also have ray AC. The two, when they meet at point A, and they create my angle. So I can name my angle three different types of ways. The first is by using the vertex, the point they meet at, and I can call that angle A. Make sure you're using your angle symbol. The next is I can use the points on each ray and the vertex. Now this is a specific type of way to do this. So here are my two examples. I have angle CAB and angle BAC. Notice what these two names have in common. A, the vertex, is in between the letters. So when we are naming our angle, our vertex must be in between our lettering. And then last but not least, if our diagram has a number, we can use that number. So I can also call this angle, angle 1. So now the next one, it says the interior of an angle is the region containing all the points between the two sides of the angle. And we also have the exterior of an angle is the region containing all the points outside the angle. So here's my diagram. You can see in the green, here is my interior points. So that falls everything in between the two rays, and anything outside of that is going to fall in the exterior. All right, so let's see some examples of naming our angles. So in example 1, we're going to do that one together. So here I could name this angle, angle PQR. Another way to name this angle would be angle RQP. And last, for this example, I can name it angle Q. So here's my three. It doesn't matter the order you write your answers in. All right, I'd like you to pause your screen and try number 2 and 3 and come up with 3 different ways to name each of these angles. All right, let's look at number 2. Number 2 actually has 4 solutions. You only needed 3. So here I have angle ZYX, angle Y, angle XYZ, and angle 1. Same thing for number 3. There are 4 solutions, and you only need to name 3 of them. All right, let's look at the next example. It says, in this diagram, angle 1 can also be named angle JMK or angle KMJ. So let's look at that diagram here. So here I'm looking at that left small angle of angle 1. They want us to now look at this angle on the right. It says, what are 2 other ways of naming angle KML? So what are 2 ways to name this angle? So 2 ways would be angle 2 or angle LMK. Notice I did not name it angle M, which leads me to my next question. From the diagram above, would it be correct to name any of the angles angle M and explain why or why not? So if I asked you which one is angle M, would you be able to tell me if I'm talking about angle 1 or angle 2 or the entire picture of JML? The answer would be no. Since they all share that vertex, it is very confusing to identify which angle we're talking about. So we cannot use angle M, and more often than not, we do not use the one letter of naming an angle. We typically send with using 3 letters. It's just easier to identify. All right, let's look on the next page. So now that we're talking about angles, we also can classify our angles. There are 4 types of angles. We have an acute angle, which is greater than 0 but less than 90, so nice and small. We have our right angle, which is always equal to 90 degrees. And notice there is a symbol notation of that box in the corner, which also represents 90 degrees. Then we have our obtuse angle, which is greater than 90 but less than 180. And then we have our straight angle, which is 180 degrees. You must know the 4 types of these angles through the duration of this course. All right, then we use a protractor to measure our angles. So when I look at my protractor, and I just took this picture, made it a little bit bigger, I can measure it. This angle actually opens up to the right, and since it's opening to the right, I'm looking at the lower numbers on my protractor because it starts with 0. So I start to 0 and I go all the way till I land to my next point. Remember, 0 was where B was, going all the way to A. and it falls at 140. So I know that this entire angle of AOB is 140 degrees. And how to write that is M angle AOB equals 140 degrees. So we can read that as the measure of angle AOB is 140 degrees. We're going to look a little more about our protractor. All right, how to measure an angle with a protractor. So it is a little funny about our protractor because you can see we go from 0 to 180 on the top from left to right, but then we also go from 0 to 180 from right to left. So when to use which side? So if our angle opens to the right, I like to use the inside numbers like I did on the previous problem. And then if it opens to the left, I use the outside numbers. So let's look at some examples and classify our angles. So here we have angle LKN. So L is here, K is here, and N. I'm just hovering over that angle so you see LKN. So here I see N starts at 0. It's really opening to the right, so I'm going to use the inside. So here I go from 0 all the way to get to L, and L lands me here. Where is it landing? It's landing in between 140 and 150 degrees. It is 145 degrees. So this angle, NKL, is 145 degrees and it's obtuse. The next example, JKL. So here is JKL. So this angle does not go towards 0 on the left or the right. It's stuck in the middle. So you can use the top or the bottom. I'm using the bottom, and I identify where both points touch on this protractor. So you can see that J is on 90 and K is at 145. So I want to find the measure between the two. So notice I wrote 90 minus 145, and I'm taking the absolute value. You can go in either direction. It really doesn't matter, as long as you know that your answer is going to be positive. So here, JKL is acute, which makes sense because it is a small angle that is less than 90 degrees. And then we have JKN. So JKN, N falls at 0. So I'm looking at that inner side of my numbers, and you can see go all the way to J. And here we have 90 degrees, and it's my right angle. All right, we're going to try a few more. All right, so here we have our protractor again, and I want you to only complete A through E, and I want you to try to figure out the measurements of those following angles. And then after you do that, classify whether it's acute, which means less than 90, right, which equals 90, or obtuse, which is greater than 90 but less than 180. All right, pause your screen. All right, so for angle AOB, you should have 35 degrees. So you can see AOB is right here on my right side, and I travel from 0 to 35. And it's also an acute angle. AOC, still on that right side, still using the inside numbers from 0 all the way to 65, making the angle 65 degrees, which is acute. Then we have BOC. So BOC is no longer at that bottom. It's a small angle up top. And here I use my inside numbers. So here I can see that angle, that line CO, that ray, is in between. It's at 75. And BO is going through 35. So here it's 65 minus 35. So angle COB, or BOC, is 30 degrees. Then we have angle BOE is 110 degrees, which is obtuse. And then we have angle COE, which is 80 degrees, and it's acute. All right, so now we have our angle addition postulate. So here it says if P is in the interior of angle RST, then the measure of angle RST is congruent to the measure of RSP plus the measure of PST. That's a lot going on. So there's a couple things to notice. We have 3 angles in this picture. So I kind of changed up this picture a little bit with a little more coloring. So what they're trying to tell me is that these 2 small angles RSP and PST, when I add them together, it creates my larger angle on that outside, the one I highlighted in green. So this is our angle addition. It's very similar to our segment addition. All right, so let's look at our first example. It says, given that the measure of PQR is 102, find the measure of SQR and the measure of PQS. So the very first thing, PQR is 102. That means the entire picture is 102 degrees. The whole thing. All three angles, this large angle, the two angles together make 102. So I need to come up with an algebraic equation to show that. So the two small angles, 9x plus 11 plus 7x minus 5 equals 102. And then I'm going to solve my equation. I combine like terms, so I have 16x plus 6 equals 102, and then 16x equals 96, divide, and x equals 6. Notice I'm not done yet because it actually asked me to find the measurements. So I'm going to take my value and substitute it into my expressions to find the measurement of the two smaller angles. So here, PQS is 37 degrees and SQR is 65 degrees. All right, so here we're going to try to find the indicated angle measure in these two problems. I'm going to start you off and then you're going to try on your own. So it says, given that angle KLM is a straight angle, find the measure of KLN and the measure of NLM. Okay, first thing is they gave you some vocabulary that sticks out, straight angle. So I need to know what a straight angle is. A straight angle is equal to 180 degrees. Because I know that vocabulary term and its value, now I can create my algebraic equation. So I know that these two angles, when combined, will equal 180 degrees. So I can say 10x minus 5 plus 4x plus 3 equals 180. All right, so now we're going to combine like terms. So here I have 14x minus 2 equals 180. Now I have 14x equals 182, leaving me with x equals 13. Again, we have to plug in to find our values. So here I have the measure of KLN equals 125 degrees, and the measure of NLM is 55 degrees. A nice way to check is if I add the two together, they should give me 180 degrees. All right, try the next one on your own. Pay attention to any key vocabulary terms given to help you set up your problem. All right, so the first thing is I can see that we have a right angle. They tell me that in the information and also on the diagram. Remember that right box is a notation for 90 degrees. So I know that these two angles together will equal 90 degrees. When I set up my equation, I have my two small angles equal to 90, and I solve. When I solve, I get x equals 28. And then I'm going to substitute back into each expression and find that each angle measure. So EFH is 60 degrees, and HFG is 30 degrees. A little more vocabulary. We have an angle bisector. An angle bisector is a ray that divides an angle into two equal angles that are congruent. So in my example here, you could see in red, the angle bisector is YW. Remember that we start our ray with its endpoint. And then because that it's my segment angle bisector, I can add those curve markings here. They're just like tick marks. They tell me where things are congruent. So this tells me these two angles are congruent, which allows me to write this statement. I can tell you that XYW is congruent to ZYW. All right, so try this one on your own, using a bisector to find the angle measure. It says given QS bisects PQR, and the measure of PQS equals 24 degrees. Find the measure of PQR. It's a lot of information, so a diagram is important. So I want to start off with just the diagram. So pause your screen for a moment and then see what the diagram looks like while you make yours. All right, so here is my diagram. All right, so the large angle is PQR, and then you can see that the bisector, the angle bisector, is QS that I put in green, and I know that each angle is 24 degrees. so I put the 24 in my diagram. So that's what your diagram should look like. You should have your angle markings, you should have all the lettering as well, and the 24 degrees should be on your picture. Now they want us to find the measure of PQR. So PQR is the entire angle made up by the two smaller angles. So if I know that PQS is 24, well, that means that RQS is 24. So I know the entire picture is 48 degrees. All right, so I would like you to try practice on your own, practice from 1 to 9, and pause your screen. Then you can go on to the next and check your work. All right, here is my solutions with my worked out values. Pay no mind to the numbers in green. That is totally for me here, nothing for you guys. But I did show you some key words. I do highlight the vocabulary wherever I get a chance. Notice I highlighted the straight angle and how that helps me to turn into my equation. That right angle here, I know it's 90, so that goes into my equation. All right. Thanks again, guys. Talk to you soon.